as previously I haven't shared the topic. So this is the topic. It's about the polymer flooding with the time varying injectivity comparing with plugging impact on the reservoir. So here I would be comparing two cases, as is already mentioned on the topic. So those are some of the related works which they have been already conducted previously. So as you know, we are talking about here enhanced oil recovery. So the target here is in order to improve the oil recovery. So it's very necessary to use some secondary methods in order to improve the recovery. As we know, with time goes, the recovery from the production or from the well will decrease in function of time. So it's necessary to find some secondary or third methods in order to enhance or in order to increase the quantity. So as production is going on, we are also facing with other problems. Here, the problem are mostly some mechanical problems. So in this research, we try to, approach in order to solve or at least having a clear understanding about some of the mechanical and impacts, and as well as some of the impacts which are on the production during the well while it's producing. Previous researchers, they have also found out some of the problems which they have occurred as during the absorption on the rock surface, mechanical entrapment, which is the blockage, the hydrodynamic retention. And they have also found several causes, as it has already been mentioned here by Serik, by Duan, by Hov, by Hu. So I wouldn't be reading the whole text. And as well as they have conducted different experiments. So now I will be going through the work straightforward. So we have proposed here in a methodology in order to approach. First, we use the polymer concentration. As we know, they have an influence on the permeability curve, which as soon as possible, I will be displaying here some of the figures, so that could help you to have a clear understanding. So the curve infiltration during the concentration of the polymer injection could have directly effects on the distribution of residual oil, the polymer flooding process on the reservoir. So the aim here of the workflow approach is to provide a numerical simulation technique for the introspecting the iteration phase, which is comparing here different phase, the water and the polymer flooding reservoir, whose rational study running the purpose of obtaining deficiency in the initial technique. So in order to achieve this operation flow, the significance of this arrangement, along with the essential of the available accomplishment, also application of theoretical model is considered. So here we have used two software in order to overcome this proposed approach. First, we have used Eclipse during the injectivity while we are injecting the polymer into the well. And another software, which is the CMG, we have used here in order to have a deeper understanding about the mechanical issue. So while the polymer flooding impact, we have approached here below some of the key descriptions based on our workflow here. So here, in a basic way, the main objective first is to have an understanding about the effect of the polymer concentration on the relative permeability, and as well as analyzing the impact factor through time varying, injectivity, and plugging on the reservoir. So the work here would just provide in general an understanding about the effects or the impact factor throughout the application of polymer flooding. So here the case one, which is the approach of polymer flooding through time varying injectivity, as you could see on the first. Sorry. So I would be presenting here the workflow. This workflow, which is in the left side of the figure, time varying of technique, which is used in order to give a clear idea how the time varying injectivity has been conducted. So different parameters, they were being applied here. As you can see, different phases, even IC1, IC2, all they were being described here through the description. And in your right side, we could see the figure, which is the figure 2, the polymer flooding plug, which is used to have an idea about the concentration, or this is about the mechanical side, which having effects on our reservoir. So some key parameters, which they were being included. So for sure, sand is here, which is present as a solid, which is the non-moving sand, which is present in the oil, and others reacting factors, which are also having effects on the oil, which with the presence of the sand, the inert sand, which is the sand is the solid or the non-moving sand, and as well as there is a moving sand also causing other effects. So below here, we could see the viscosity changement component, which is the viscosity changing in function of time during the polymer injection with the water. And here, which we're talking about the blockage through the porous media, and as well as the permeability changement. And here, finally, we could see the polymer plug on the reservoir. So based on the above description, here we are here to achieve those objectives. So here, the first case, based on our first figure, which is the time variation injectivity, we have the polymer shear effects when the water phase velocity rise. So we can see exactly on our figure 3 here. So we see here when the water phase increase in function of the shear velocity, here is completely decreasing. While in our first figure, here we could see the polymer viscosity. When the concentration increase, the viscosity of the polymer also increase. We can see when the concentration increase, our viscosity of the polymer also is increased. And here on our fifth figure, we have the polymer absorption, while the polymer saturated concentration reduce, the concentration of polymer rise in function of time. This is the polymer absorption figure, which we can see the increase. And finally, we have the sixth figure, which is the permeability curve in function of the infiltration of the delta increase, which is during the polymer injection. So in this one, we see when the permeability of the oil decrease, the water increase, which is in function of the polymer. And we can see here there is any shifting. The shifting which has been impacted directly by the injection of the polymer. So here, based on the above approach, we could see here the effects directly on the oil production, as well as comparing with the above, which are here, mostly are part of the mechanical side of the during the injectivity. That's mean what's occurring in our reservoir. So here we're seeing about in the production side. So the oil production rate field, we can see in our figure 7 here. So we'd see at first our production has started on a rate. Directly it has dropped, and then it has increased, and within 1,000 days it has completely dropped, and we would see it's decreasing, which is the field production rate. So that's mean the production rate, it has been intact rate on a specific given rate, and the decrease is quite higher and quite fast. While in our right side here, the liquid production rate. So the major impact on the liquid production rate here started with a rate of 60. It has dropped faster, and all this majorly impacted by the presence of the mechanical, which is the sand and the broken rocks during the injection of the polymer flooding, which is directly having an effect. We could see there is an injectivity lost here in 1,000 days. We could see that's a direct effect. So then we go in case B, which is a part of the polymer plugging, and that plugging is also part of the blockage, which is the solid concentration. It's having directly the solid is blocked with the core of our reservoir. But here we can see on our 2D the presence of the solids with a given concentration of a portion of 0.005 concentrated along the nearby the producer well, while the concentration nearby the injector well with a rate of 0.0053, and based on this year. So we can observe that in function of time, the concentration has they have increased in the position of the producer well, which are positioned in the corner, while the injector well is in the center. So nearby the injector well, the concentration, the presence of the blockage, which is part of sand and broken rocks, they are lower, but nearby the producer is higher. While here in the next figure, we can see in our right side, the concentration of the solids have completely increased. We could see the rate has increased. So nearby the producer well, it has increased, as well as the nearby the injector well, it has increased. So in our figure 10, we can see the concentration has increased higher compared to the previous figure 9. Even the concentration rate portion has increased. Within a year, we can see here in 2020, the 11.3 alongside the model, we can remark also the solids also concentrated highly nearby the injector well. So that we can also see on the here the producer well, the liquids, the effects of the concentration of the solids on the liquid production rate, as well as on the oil production, field oil production rate. So below here, we can see at first the rate has started increasing till once it has reached in the year 2017, directly it has dropped. So that's mean the presence of a solid, which is the sand or broken rocks, have already blocking the pour of the oil. That's why it has completely, the rate has dropped, and then it has increased. Even with the increased, is still the rate is stable for some year, but surely it will decrease after a moment. And we can see on our oil production rate graph here, which is the leakage rate has started stable for some year. With this same year on the liquid production rate here on our oil production as well, it's stable, but it has decreased more lower than the field liquid production rate. So based on the outcome, we can say that the major effects on the liquid production rate, oil rate, during the injectivity, the solid phase concentration with the frequency factor blocking and causing the permeability to decrease, oil rate to decrease, liquid rate to decrease. And the solid phase concentration, which is the major factor which is affecting on the liquid rate, oil rate, permeability to decrease during the polymer plugging, and as well as during the injectivity, an issue which is on the reservoir production rate. So on our conclusion, based on this work result, the variable which are initiating impact during the polymer injectivity and plugging on our reservoir is as following: migration of solid concentration during the polymer flooding, initiating plugging, permeability reduction, polymer plugging followed by the frequency factor affecting the reservoir production rate to lessen in function of time, and solid concentration, debris, and frequency factor are the major impacting factor on the reservoir. And here are some of the previous works or the references, which are very useful for anyone who's interested to conduct any research which is similar, or to have any broad idea. And thanks, I do have finished, and thanks for your attention. You are highly welcome.